morning, everyone. Hope you all safe with the good health. With you, Ms. Dina Al-Badri, physics teacher for grade 12. Today, we will start new chapter 22, electric current. In this chapter, we will talk about the electric currents. Electric currents carry electric energy that can be transformed into other forms of energy. Electric current is the flow of the electric charge. So, what is the electric current? How can you think about the energy in the electric circuit? And what is the Ohm's law? So, there is three main ideas that we will talk about. The meaning of the electric current, how can you think about the energy in the electric circuit, and what is the Ohm's law? Okay. First of all, we will talk about the electric potential difference. Electric potential difference, the work done moving a positive test charge between 2 points in an electric field, divided by the magnitude of that tested charge. Flowing water at the top of the waterfall had both potential and kinetic energy. However, the large amount of natural potential and kinetic energy available from resources, such as any falls, are of little use to people or manufacturing who are 100 kilometers away, unless they can be transported eventually. Electric energy provides the means to transfer large quantity of energy over great distance with a little loss. This transfer is usually done at high potential difference through power lines. Once this energy reaches the consumer, it can easily be converted into another form or combination of forms, including sound, light, thermal energy, and motion. Because electric energy can so easily be changed into other forms, it has become indispensable in our daily lives. When two conducting spheres touch, charged flow from the sphere at a high potential to the one at lower potential. The flow continues until there is no potential difference between the two spheres. A flow of a charged particle is an electric current. In this figure, we say that two conductors A and B, that you see here, conductor A and conductor B, are connected by a wire conductor C. Charge flow from the higher potential difference B to the lower potential difference A through the conducting C. The flow stops when the potential difference between A and B and C is zero. The direction in which a positive test charge moves is called conventional current. Usually, it is the negative charged electron that flow. The flow of electron and the direction of the conventional currents are in the opposite direction. You could maintain the electric potential difference between B and A by pumping charged particles from A back to B, as illustrated in the figure. Since the pump increases the electric potential energy of the charge, it requires an external energy source to run. This energy could come from a variety of sources. One familiar source is a voltage or galvanic cell converts chemical energy to electric energy. Okay, and what is the battery? Battery is made up of several galvanic cells connected together. A second source of electric energy, a photovoltaic cell or solar cell, change light energy into electric energy. Okay, did you see electric circuit here? The charge in the figure move around the closed loop, cycling from pump P through C to A and back to the pump, and so on. Any closed loop or conducting path allowing electric charge to flow is called an electric circuit. So, what is the meaning of the electric circuit? Any closed loop or conducting path allowing electric charge to flow is called an electric circuit. A circuit includes a charge pump which increases the potential energy of the charge flowing from A to B, and a device that reduce the potential energy of the charge flowing from P to A, and so on. The potential energy lost by the charge QV, we call it QV, okay, moving through the device is usually converted into some other forms of energy. For example, electric energy is converted to kinetic energy by a motor, and to light energy by a lamp, and to thermal energy by a heater. Okay, there is an example of converted energy from one form to another form. A charge pump creates the flow of a charged particle that make up a current. Cannot be created or destroyed, but they can be separated. Okay, and we know that it is the conservation law of charge, like conservation law of mass, like conservation law of energy. The total amount of a charge, the number of negative electrons and positive ions in the circuit doesn't change. If one coulomb flows through the generator in 1 second, then one coulomb also will flow through the motor in 1 second. Charge is conserved quantity. Energy is also conserved. The change in electric energy, delta E, equal QV, because Q is conserved. The net change in a potential energy of the charge going completely around the circuit must be zero. The increase in potential difference produced by the generator equal the decrease in a potential difference across the motor. Again, increase in the potential difference produced by the generator equal the decrease in the potential difference across the motor. Power, which is defined in a watt, measures the rate at which energy is transferred. If a generator transfers 1 joule of kinetic energy to electric energy each second, it is the transferring energy at the rate of 1 joule per second or watt. The energy carried by an electric current depends on the charge transferred and the potential difference across which is moved. Thus, E equal Q by V. The unit for the quantity of the electric charge is the coulomb. The rate of flow of the electric charge, Q divided T, called the electric current, is measured in coulombs per second. Electric current is represented by I equal Q divided T. A flow of 1 coulomb per second is called ampere. The energy carried by an electric current is related to the voltage, so E equal Q by V. So the current I equal Q divided T, and the power P equal E divided T. So we can calculate the electric device can be determined by multiplying voltage by current. So power P equal I by V. Power is equal to the current times the potential difference. So V is a potential. Okay, that's all today. Next time, inshallah, we will talk about Ohm's law. Hope you all understand. Thank you.